Hi, this is Margo. This is Sunday evening, May the 1st, 2022. I hope everyone is safe and doing as well as possible. I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube. We're going to look at methane and sea ice and a couple of other things. And I'm doing better. I'm recovering from this whole ordeal for the last month and a half, going on 2 months now here at my apartment. And I'm recovering, and I'm actually on the upswing and doing better. And still not 100% yet, but getting things under control. So, we're going to start with the NOAA methane data. I have 2 days worth to show. I haven't shown yet. This is for the 29th, which was Friday, for the Met-Op-B or Met-Op-1 satellite. That's the only one that we're getting data from right now. For the 477/469 millibar reading, and this is in the morning, the mean or average was 1924 parts per billion. The high reading, see, it spiked up, it was 2731. Now that is a high reading. Normally it's not that high. And then in the afternoon, see, it went way down. It was 1921 on the mean, and the high reading was 2400. And then for yesterday, the 30th, the mean was 1924 in the morning. The high reading was 2488. In the afternoon, the mean was 1923, and the high reading was 2326. So for the 30th, that averages out to be 1923.5 parts per billion. That gives us an overall increase for the week of half a part per billion. So our little blue line is just, it went up just a tiny bit this week, and the week before it went up 3.5. But we're in the rising season now as the northern hemisphere heats up, and we're 15.5 parts per billion higher than we were a year ago. We're 54 parts per billion higher than when I started recording this on March the 1st of 2019. So it just keeps going up more each year. Exponential. And then in the cooling season, it doesn't go down to the low point from the year before. So you can see that, we're just on a runaway, going up, up, up. And that's very bad. So, see what methane did this week. Here we were on the show last week. For Saturday, it was at 1923. And Sunday, it went up half a part per billion. Monday, it went back down half a part per billion. On Tuesday, see, it zipped up 2.5 to 1925.5, and at that point we were 22 parts per billion higher than a year ago. Then on the 27th, It went down 1 part per billion. On the 28th, it went up half a part per billion. And then on the 29th, it dipped, pretty good decrease of 2.5 for that day. And then on the 30th, it went up 1 part per billion. So it fluctuates quite a bit, but we're on an overall increase, giving us overall for the week, like I showed, an increase this week of half a part per billion and 15.5 parts per billion higher than we were a year ago. So there's that. Now we'll look at the CAMS data. I have Saturday the 30th loaded up, the Arctic view and surface level. This is from Copernicus Atmosphere Monitoring Service. They're out of the EU. And this is a model. They take data from all different places and then put it together in their model with algorithms and things. And so there's our color ledger at the bottom. The data is for Saturday, and forecast period is Sunday through Wednesday. So as we watch it load up here, see these yellows next to the greens? That's where the methane is coming up through the sea ice. Here in the Laptev Sea and Chukchi Sea, also in this East Siberian Sea, see there, right off the coast of Siberia. Also up here in the Kara Sea. We've got high readings on the north coast of Alaska at Koktovik. See, it's also coming back to life here in southern Alaska as it's starting to heat up. There's a lot of permafrost in Alaska. And lots of permafrost all across Russia and then northern Canada, of course. And we're seeing this hot spot in this North Atlantic. That's really percolating there. And then on land, here we can see it from Norway over. See, there certain days it really heats up, like certain days in different areas. The interior of Russia, see, we've got these hot spots coming across. And then Canada, and then North Dakota. Someone left me a comment saying that they thought that this was probably more likely because of the Bakken oil fields. And it could be. It's a whole combo plate. There is a big lignite coal mine in that area too. But I looked up Bakken. I'm going to pause this. I'm going to show you what I found. And I'm always happy for people to give me information. I don't have the time or energy to research all this extra stuff. So this Bakken formation, it's a huge area. it's a rock unit from the late Devonian to early Mississippian age, occupying about 200,000 square miles or 520,000 square kilometers of the subsurface of the Williston Basin, underlying parts of Montana, North Dakota, Saskatchewan, and Manitoba. So it's a pretty huge area. It was initially described by geologist J.W. Norquist in 1953. The formation is entirely in the subsurface and has no surface outcrop. It is named after Henry O. Bakken, 1901 to 1982, a farmer in Tioga, North Dakota, who owned the land where the formation was initially discovered while drilling for oil. And it's so here's a map. We can see here's North Dakota, here's Montana, and here it goes up into Canada there. Bakken Reservoir Fields in Williston Basin. And it goes pretty far Elm Coulee Field. And there's quite a few maps here. So this is just on Wikipedia. Look at this. The research paper by USGS geochemist Lee Price in 1999 estimated the total amount of oil contained in the Bakken Shale ranged from 271 to 503 billion barrels, with a mean of 413 billion barrels, while others before him had begun to realize that the oil generated from the Bakken shales had remained within the Bakken. It was Price, who has spent much of his career studying the Bakken, who particularly stressed this point. If he was right, the large amounts of oil remaining in this formation would make it a prime oil exploration target. So, there you go. And here's the history and whole thing. How much they produced, etc., etc. And there was a boom in North Dakota, an oil boom, and it's given those who own mineral rights large incomes from lease bonuses and royalties. The boom has reduced unemployment and given the state of North Dakota a $1 billion budget surplus. North Dakota, which ranked 38th in per capita gross domestic product, or GDP, in 2001, rose steadily with the Bakken boom and now has per capita GDP 29% above the national average. So they're doing pretty good there, as long as they're able to keep drilling. But, you know, it does produce a lot of methane. And then here on USGS, they have a bunch of information on it. How much oil and gas are actually in the Bakken formation. USGS estimates that there may be 1.3 to 7.3 billion barrels of undiscovered, technically recoverable oil in the Bakken Formation. An additional 4.9 trillion cubic feet of associated dissolved natural gas and 0.42 billion barrels of natural gas have been estimated. These are mean values for undiscovered volumes. Approximately 4 billion barrels of oil were produced from the Bakken and Three Forks formations to date. So they've got a lot of info there. So I'll leave those links below if you want to learn some more about that. So I want to thank that member or subscriber for commenting. That was interesting. So that's this area here that we see in North Dakota that goes over to Montana and streams up into Canada. So we just learned something about that. And now we'll go to the North Pole view. And, I know they're trying to get off of oil, but, there are not other systems in place yet for us to really get off of oil. I don't really see us completely getting off of oil. And there's so many products that use petroleum in, in medicine and hygiene, everything. I just don't see us ever getting off of petroleum or oil completely. I just don't see how. I don't think we're going to be here long enough to even try and figure it out. So here we're looking at the North Pole view, and let's see, the UK's filling up pretty good there. And here in the North Sea, we have different hot spots here and off the coast of Norway, and see these higher readings in the Atlantic. Now that's kind of calmed down. That had been streaming across to the west earlier this week, so that seems to be calming down a tiny bit. Still high in Germany and coming down. Here's the Persian Gulf. Here's India and China, and see, it's spilling over these coastlines here in southern China. And right now we're only seeing greens here in the Bengal Bay. So as it starts heating up, we'll see it spilling over more and more. And then here in North America, specifically in the U.S., see this northeast coast. Look at that. You see the blobs coming in. That's it's after it's rained, and it's a few days later. We got the methane. Look at that. So it just depends on the day and the weather, and also the oil drilling, but also the densely populated areas they have much higher methane as well. And see, California, like that's always going. West Texas, that's always going. That's, no, West Texas, that's from oil. There's a lot of oil drilling in California too. It's all over the place. Now we'll pop down to the Antarctic. And what you're going to see is these higher readings are taking over the southern hemisphere. Methane is redistributing as these higher readings come in. See, now the main background color down here is this brighter aqua, which is 1840 rather than the 1820. And see, you can see it taking over as we go into the forecast period. So higher readings expected in this forecast period. See, just covers up, takes over this whole Antarctic region. We can still see a little bit higher reading on some of these hot spots, like here at the Brunt Ice Shelf and on this western peninsula. We can see it, but it's hard to tell the difference when it gets up to 1940, because if it's at a 1960 reading, like here on the Brunt Ice Shelf, you can just barely see that when that pops up. And we can see it popping up here on this western peninsula. Also here on the Amory Ice Shelf. Now it's almost all dark down here. We'll see that when we look at NASA Worldview. Now we'll go to the global view. See, you can see that that aqua really taking over. Just very little 1920 left. I mean 1820 parts per billion. And New Zealand, see, it's picking up, especially that North Island. And over here in Australia at Sydney, that's popping off. Look, on this northeast edge too. So main background color in the northern hemisphere is some shade of green. From this dark green, which is 1920, up to the bright green, or even like the chartreuse, that's 2000 parts per billion. Alright, now we'll look at 500 HPA. That's about halfway up in the atmosphere. This is about the same level as what we're looking at on the NOAA data. So here our heaviest readings are over this northern part. Now see, it is swooping down into southern China. And see, we're getting more yellows further south and reds as methane is going up. It's redistributing, and it's going up too. And here's the global view. Here are our highest readings here in China and here in eastern India. And then we've got reds coming across. But like I said, it's redistributing. There's not nearly as many reds as what we saw earlier this year. So there's that. Now I want to go through this CAMS data for today. Here's sulfur dioxide readings for today. We've been seeing some higher readings on this west coast of South America. Also, there have been some releases here in the Arctic this week. I don't know if it was from plate movement or what, but it was pretty dramatic. We have some left over up here. And also, we had some higher readings from Krakatoa that had been going off this week. It's down here in Indonesia. And here at 500 HPA, here's leftover here off the coast of South America. Here, Colombia. Here's at Popocatépetl. And here's what we have left over in the Arctic. See, it's swooping across from Greenland over to Svalbard. And then we've got some higher reading here in China. And here's the Arctic view for sulfur dioxide. See China there. I'm assuming, I don't know, that could be from fires there in China. Usually when we see red in China, it's from pollution. But it just depends. But they do have quite a few fires too. Here it is at 500 HPA. And see, here's where it's coming across the Arctic there. Also, here over Russia. And there it is over China. And now we'll switch to ozone. Here we are looking at the Antarctic. We can see it's thinnest over this western peninsula. This part is still in the sunlight. The rest of, most of the rest of the Antarctic is in the dark now. And we're into the aqua, which is getting thin. The solid yellow is 300 Dobson units, and that's considered average or healthy. And then when you start seeing it change into greens and blues, that's getting thinner and thinner. So we're seeing the hole form now. It's beginning to form as it's cooling down in the Antarctic, and these big breaks. See, and here's the Arctic view of the ozone, and it's thinning out up here. And here's the global view. And look at all these greens and this whole southern hemisphere is mainly in greens. And these holes are getting bigger. Look at this. It's awful. It's not even Swiss cheese. It's just huge holes. It's very bad. That's all of those. Now we'll move on. Looking at sea ice, we're going to start with our Navy models. Here we're looking at the Arctic sea ice thickness for today. The thickest ice is right here on the Canada coastline, up to 5 meters thick. That's the dark red. And along the Greenland coastline. And then the greens are about 3 meters thick. And then we can see that most of the ice is in some shade of aqua, and that's from 2 to or like if it's dark aqua, it's about 1.5 meters thick, like what we're seeing here next to Svalbard and Franz Josef Land. And up here in the Laptev Sea, see it's dark aqua, and it's coming more into the darker aqua as we move towards the North Pole. The bright aqua is about 2 meters thick to 2.5 meters thick. So the thickest is just above Canada and Greenland, and a little bit here in this Chukchi Sea. But it's thinning, and we're not noticing that much change in the extent. It is decreasing on the extent, but we're starting to see it thinning now. And here in the Bering Sea, you can see that's in high melt there. Also, the Bering Strait is clearing out, and the Sea of Okhotsk around the coast of Russia, that's melting. And then as we come in, here's this hole off the coast of Alaska, and see it's still there. And here in quadrant 1, mainly aquas, and we can see this Laptev Sea is melting, going from lavender around the coastlines and purple, moving into the dark aqua, coming across. And then here in quadrant 2, we've got a combo of purple and lavender, and then some aqua. This is going to melt fast with this Atlantic, the water from the Atlantic coming in that's warmer. Here in quadrant 3, it's mainly Greenland, and it's just starting to thin out, and it's melting around the southern tip of Greenland. We can also see it's melting on this coastline of Canada. Also down here in the Hudson Bay, it's melting, especially on this west coast. See, and these tributaries are still pretty much aqua, these will start thinning out as things melt out. Here in the north part of the Baffin Bay, we can see a big hole there. And then here in quadrant 4 is where we see the majority of the thicker ice along the Canada coastline, and then just building up, coming out a little bit. And then here in the Beaufort Sea, we've got mainly bright aqua, so about 2 to 2.5 meters thick there. So let's look at the 30-day animation. This was updated to yesterday, so the data goes back 3 weeks, and the forecast goes out to next Saturday. So let's see what they're showing on the forecast for this week. Well, let's start down here looking at this Hudson Bay. Yeah, that's melting. You can see it shifting. Watch here on this west side. And then can't see here by Canada. And this extent in this Baffin Bay that's starting to decrease. See, and especially in the forecast period, when you see the white, that means it's melted, just going into nothing. Also on this east side of Greenland, this is all going to go into high melt. And let's look up here in quadrant 2. So here in this North Baltic Sea, we can see that's diminishing. What little ice is there? It didn't refreeze much this year. And then here where the Atlantic comes in, now watch here in the Carana Sea, so that's breaking up. Mainly what you're going to be seeing is a lot of thinning. You're going to see these colors change. See, in the forecast period it goes more towards this dark aqua. You can see it shifting. And then see this Bering Sea, that's in high melt. And the Sea of Okhotsk, see that? It's moving into the very light lavender, meaning it's just very little ice. And what's there is moving into thin, very thin, and a lot of space in between the pieces of ice, so a lot of melting. And then watch here, see it's melting here around Alaska. And it's just in the beginning stages of breaking apart. So we'll see that as well. Now we'll look at the Beaufort view This Beaufort Sea here. Alaska's at the bottom. Canada's on the right. So here's all we have of that thicker sea ice here by Canada. Not much. It's just not much at all. And then here's this hole on this Alaska coastline. And here's the 30-day animation. This was updated to today. So the forecast goes out to next Sunday. And we can see that ice drift is pulling it away from the coastline here. Watch. Let's see. We can also see the leads opening. So these cracks are beginning to form. See that? Here, I'll stop it. There we are on the next Sunday. So this is the very beginning of the melting, where you see these cracks starting to open up like that. And now we'll hop down to the Antarctic, where it's refreezing and still below normal, but it is refreezing. And you see where look how it's come out on this Weddell Sea, and this is the majority of the thickest sea ice here in the Weddell Sea, and a little bit over here on this west side as well. Here's the 30-day animation, and again this was updated to yesterday, so the forecast goes out to next Saturday. So we're starting to see some thickening, like here in the Ross Sea. So it's moving into the darker purple, which is about 1 meter thick. And see the extent moving out here in the Weddell Sea, and a little bit more thickening. And same thing here. Now the Thwaites Glacier is right along here, and Pine Island Glacier is up here. There's that. And then here is National Snow and Ice Data Center as of yesterday. And this is sea ice concentration in the Arctic. We're seeing more blues as it's starting to break apart and getting thinner as the melting has begun. And like I said, not much change in the extent, but it's starting to thin out. We can look here in the Laptev Sea and see all these blues here in the Kara Sea and in this Barents Sea. Also more shades of blue in the Baffin Bay, and these blues where it's melting here in the Bering Sea and the Sea of Okhotsk. Here is their chart for sea ice extent. Guess they had some missing data for a couple of days here. The blue line is this year, and we can see it's on a downward curve. This dotted line is 2012, and the gray line is the median. We're still below the median, And we're still below 2012 for this time of year. And now the Antarctic. Here's our refreeze, and we can see the gold line. That's the median. So it's well below that down here on this west side. Look, missing data here too. And here's our refreeze this year, and here's last year with the green line. So we're still well below last year and the median on that. And we started tracking Greenland. They just brought that back online week before last. And here's our melt today. See the salmon? Got quite a bit of melt on that southern end. Well, that's yesterday, April 30th. That's the ice sheet on Greenland. And here's the total melt days for this year. And it's just by colors over here. And we can see around the 10 to 15 day range right down here. And then we've got more blues. So it's picking up, see, all around this southern edge. Here's their chart for the melt extent. The red line is this year, the dotted line is the median, and we can see a little spike in the melt as of yesterday. And so that's why we saw the salmon color. So we've got some early melt going on here. And we can see in past years where it's melted this early. But at the median is a flat line for right now. That's all of those. Now, let's look at Climate Reanalyzer. Here's 2 meter temperature anomaly. We've got browns over a lot of the Arctic region there, and then blues. See these reds over the Antarctic. It's warmer than normal. And we've got browns in southern Russia and Mongolia and Kazakhstan, browns and reds there, and swooping down all the way into India, and so on and so forth. Worldwide, we're up 0.2 C, higher than normal. The northern hemisphere is up 0.4 C. The Arctic is up 0.3 C. The Antarctic is down 1.9 C. Southern hemisphere is down 0.1 C. The tropics are up 0.3 C. Precipitation and clouds. We've got rain on the coast of Norway there, and then snow. We've got some, the blue is snow. Look at this big system in the Pacific next to Alaska and Canada. That's rain. So Here's the flat view. Here's what's left of the jet stream. It's just these weird pieces. It looks weirder all the time. More disjunct. And see, now we've got it streaming from the north down into the south. So you can't tell whether that's for the southern hemisphere and northern hemisphere. So that's not good. Here's sea ice and snow cover. Now as this really goes into high melt, we'll do a slideshow of the daily so you can see the melt. Right now it's hard to tell much except just around the decrease around some of these coastlines. Here's sea surface temperature anomaly. This is for yesterday. And pretty soon you're going to start seeing more browns up here as the ice starts melting. Look, we've got browns already around this coast of Alaska. See where the ice has melted. And we've got even like reddish brown here around Iceland, and these interior bodies of water are starting to heat up. And see this Baltic Sea, that's almost all brown. And look here next to Finland, that's moving into the red. We've got brown in this whole North Atlantic. And all constant hot spots off the coast of Canada and the US, and the Gulf of Mexico was almost all brown, moving into red. Look here, this is the Arabian Sea, that's really heating up. See, it's moving into reds. Caspian Sea, see, it's brown and it's got a little red spot there. Mediterranean Sea, see, it's starting to move into some browns here. The Red Sea, Persian Gulf, all of those are starting to heat up. Worldwide, we're up 0.3 C higher than normal, along with the southern hemisphere and North Pacific. The northern hemisphere is up 0.5 C. The North Atlantic is up 0.4 C. And the equatorial Pacific is down 0.3 C. And that's this area that's in the blue, equatorial Pacific. Now, let's move on. Okay. NASA Worldview. We'll refresh. Here it is today, and we're starting with the Antarctic. And see, that's where it's gone dark with the model. So I wanted to show, though, let's go to yesterday, this iceberg A76 that we're tracking. It is on the move. It's still moving. I can't find it. Here we go. There it is. See, right there. Here's the Western Peninsula. This is the 29th. And here's this western edge of this iceberg. And it's got quite a bit of momentum to be pushing through that sea ice. And it's still pushing through. I can't believe it. I thought it would be stopped by now, but it's moving. And you can just barely make it out yesterday under the clouds. And then today it's underneath the black spot of the model. But we can turn on the sea ice concentration layer, and where you see the pinks, that's the opening around the iceberg. So we can track it like that too and see where it is. So it's moving out. I still think it's going to get frozen in. But that's about all we can see right now. Oops. Trying to use my mouse. I don't use my mouse much anymore. I mainly use my tracker ball. But when I do these shows, I use my mouse and my tracker ball, one in either hand. So here we go. Now we'll look at the Arctic. Here we are today. And look at this. This is the sea ice concentration. Look at the change. See all these colors? That's where it's melting. See? See where it's going into darker pink and red, and then going backwards in the rainbow as it's melting more and more. So that's it's already, look at this. Here in the Laptev Sea, we've got holes. You can see there. Here it is around Alaska, and there's the Bering Strait. Here's the Bering Sea. Look at how all that's melting. And more pinks. Very little white where it's concentrated to be solid. And see, even up here, this is at that bottleneck where the nearest strait comes down to this Baffin Bay, and there's that hole. So that matches up with the Navy model that we saw. So let's just now take a peek with the satellite view. So we'll start right down here. This is Greenland, and this is Ellesmere Island, and here's the nearest strait where it comes down, and here's the very end. So we can see that's already in high melt, and it never froze solid this winter. Look at all this open water. See the blue? And see right along the coastline, it's pulled away. And see, as we come down, this is the west coast of Greenland. Look at all of that breaking up. This is an exceptional view today. Look at this. This inland, this little gulf area. See, a lot of open water there already. Look at this. And then there's the edge of the sea ice. And see, this is open by Greenland. Here's the southern tip. Now we'll come up this east side. See, there's the ice. It's melting. Now there's a cloud. Here we go. See? Look at this. Here's Svalbard. There's the ice next to it. I want to come back around. We've got some clouds here. I want to show the rest of this nearest strait while I'm at this. Now here's the Lincoln Sea. And see, we've got open water here as it leads into the nearest strait. Look at all of that. And then there's the pieces of ice. Now we're under a cloud, and you can see the ice there, and a lot of open water in between those pieces. So there's that. Now let's go back. So we saw Svalbard, and here's Franz Josef Land. Look at, see all this melting. Look at these cracks. Those are the leads. Leads. Those are the long cracks. Those open up first. A lot of open water on this east side of Franz Josef Land. Look at this. And here's some more ice. And there's Novaya Zemlya. Look at this. Look at how it's melted already around the coastline. That's quite dramatic, isn't it? Could have just pulled away and then melted out. So here's the Russia coastline, and then here's the Yamal Peninsula. Look, it's already opened up here. And then this is the Kara Sea. This will melt very fast. Look at this. Melting, melting. And then this is Severnaya Zemlya. This island is Komsomolets. This is where we saw methane billowing for a couple of years, and now it's magically stopped. And there's a lot of open water there. And there's open water here. And here. And then this is This is the Laptev Sea. See, it's opening up on that coastline. Look at all of these cracks. Look at this. Now this is the area where, the first area where Natalia and Igor did some of their methane studies and discovered huge deposits of methane in the sediment in the seafloor that were already melting, and that was years ago. So, and then they've done more studies since then, and there's methane in all these sediments. The clathrates. And here's New Siberian Island, and there's some open water there. It's under a cloud, and here along the coastline. Now look at this. See, it's cracking up. And then there's Russia, that's Siberia, and this is the East Siberian Sea, another area with huge methane deposits. Look at that. See, that's cracking. Here's Wrangel Island. It's under big cloud right now. Coming on around. There's Alaska. See, there's a whole, oops. And look at this Bering Strait. It's opening up. Look at that. And then here's the Bering Sea. Look at how that's melting. Not much ice left there. Look at that. And we've got some clouds there. And then let's look at Russia. There's Kamchatka. See there. And here's the Sea of Okhotsk. There's a little bit of ice there. And a little wispy ice here. Not much, huh? There's a little. So that's melting fast. Now we'll come back. Here's Alaska. See, around the coastline. And here's where it had pulled away. There's a little refreeze there. Not much though. So look at, that's breaking up. And coming on around. This is the Bering Sea. See all these cracks? Look at this. So here's this is, I think this is Canada here. Open water. See that? See the open water coming around. Look at this. And so along this coastline, this is where we have the 5-meter thick ice. The sea is pulled away. And then out to about 3 meters thick, coming up to Ellesmere, and then 2 meters out here, 2 to 2.5. So let's look some more at this Beaufort Sea. Some years this just melts out really fast. Other years it's a little bit slower. And then there's Ellesmere Island, and it's in a cloud. So that's what we've got here. Now, let's look at the earthquakes for the week. Well, today we've got 233. We don't have any huge ones. Fives, we've got some fives. 5.2, Tonga. 5.5, Volcano Islands, Japan. 5.3, Izu Islands, Japan. And then we've got fours. A lot of fours. I wanted to show. Let's look at 7 days, all magnitudes. (1,883) earthquakes this last week. We had some more Arctic earthquakes. We had 2 up here. One in the Norwegian Sea and one in the Greenland Sea. 4.3 and 4.2 right on the plate line. That's why I'm thinking the sulfur dioxide that we saw was from plate movement up there. And then another one in Tiksi, Russia, a 4.4. And remember last week we saw 2 up there. Here's one on Kamchatka, 4.2. And we had 6.0 off the coast of Methane, Papua New Guinea. That was, I think that might have been the largest one this week. We had activity up here in the Aleutian Islands, 5.2 in the Chignik, near Chignik, Alaska. And just looking for some larger ones. And look at all this activity coming up through Greece and all the way up to Poland, 4.5, Rudna, Poland. And so on. I mean, just lots of earthquakes. Here we had one, 5.6, Central East Pacific rise. And just more of the same. Let's see. 7 days, 4.5 magnitude and higher. Let's see. That takes it down, doesn't it? We're just looking at the largest ones. It's still a lot. 76, a 4.5 magnitude and higher. And I wanted to briefly just show a couple of things off of Sam Carana's website, arctic-news.blogspot.com. There's some new stuff here. This is from Wednesday, April 27th. Carbon dioxide crosses 422 parts per million. It's at Mauna Loa, Hawaii. So another record there. Furthermore, very high methane levels were recorded recently at Mauna Loa, Hawaii, with surface flash readings appearing to be as high as 1955 parts per billion. That's high. That's very high at Mauna Loa. And then it goes into carbon dioxide equivalents, and there's just a lot of good stuff here. So I recommend everyone go over and check out Sam Carana's latest posts. And there are other people who post here too. And then here from April 16th, runaway temperature rise by 2026. March 2022 temperature anomaly. Look at all of this over the Arctic. Between 4 and 6.8 temperature anomaly over the Arctic. Says Arctic is heating up strongly. The above image shows a temperature rise for March 2022 of 1.06 degrees C, which is the rise from 1951 to 1980. The image below shows a temperature rise from 1900 for March 2022 of 1.36 degrees C. The box on above image shows that when including further adjustment, the temperature rise for pre-industrial to March 2022 could be as much as 2.35 degrees C. I don't doubt that. Details of the adjustment are described at the pre-industrial page. Yeah, he's done a lot of different analyses on that. A 2.35 degree C rise is only 0.65 C away from a 3C rise, and as described before, a 3C rise will likely drive humans and many other species into extinction. You know, I've thought that we were above a 2C for a long time, just because we're already seeing so many effects of the higher temperatures. Anyway, then he goes into more analyses. Runaway temperature rise. A strong El Nino combined with high sunspots could cause the global temperature rise to cross 3C in 2025. I'm thinking we could cross it before then. Moreover, this could trigger a runaway temperature rise starting before 2026, where the temperature rise is felt most strongly in the Arctic, especially during El Nino events. So we know what that means. Melting of all the sea ice, and then methane blowouts, and you know what that means. Heating, exponential heating within a very short period of time. And then this is from Friday, April 8th. Global Warming and the Fermi Paradox by Andrew Glickson. And he says, just as individuals can be plagued by insanity, so can groups of people. I'll agree with that. So, Earth system moves to a new state, severe challenge to contemporary civilization, possible collapse, ? Look at this, mean Arctic, 7C. So, that's a good one to read. And then Tuesday, April the 5th, shortcomings of IPCC, mitigation of climate change. The report has severe shortcomings, including the IPCC makes it look as if the temperature rise could be restricted to 1.5 C above pre-industrial, and insists there was a carbon budget left to be divided by using monetary analysis. This narrative results in a failure to highlight some key drivers of change, such as heat pumps in buildings and air taxis in transport, and in inappropriately referring to such key drivers of change as options, while failing to mention the best policies to achieve the necessary changes, i.e. through local rebates. So, anyway, he's got a long discussion there. And, they need to confirm methane's importance. A lot of times they don't take into account the permafrost and the thawing out of that. Look, catastrophic methane rise, etc., etc. And we've been seeing it just in what I track. So it's not looking good. And these end days were prophesied of in the Bible, mainly by Jesus, but a lot of other prophets too. But, Jesus was much more than a prophet. He was the Son of God. And in Revelation, there are many things that are coming to pass now. We're in the middle of all of these things. So I like to bring things back to a spiritual standpoint, a spiritual perspective. And we're still reading out of the book of Ecclesiastes. There are 12 chapters, so we'll finish up next week. And Ecclesiastes was written by Solomon. He was considered the wisest man. Ecclesiastes chapter 11. Cast thy bread upon the waters, for thou shalt find it after many days. Give a portion to 7, and also to 8, for thou knowest not what evil shall be upon the earth. If the clouds be full of rain, they empty themselves upon the earth. And if the tree fall toward the south or toward the north, in the place where the tree falleth, there it shall be. He that observeth the wind shall not sow, and he that regardeth the clouds shall not reap. As thou knowest not what is the way of the Spirit, nor how the bones do grow in the womb of her that is with child, even so thou knowest not the works of God who maketh all. In the morning sow thy seed, and in the evening withhold not thine hand, for thou knowest not whether shall prosper either this or that, or whether they both shall be alike good. Truly, the light is sweet, and a pleasant thing it is for the eyes to behold the sun. But if a man live many years, and rejoice in them all, yet let him remember the days of darkness, for they shall be many. All that cometh is vanity. Rejoice, O young man, in thy youth, and let thy heart cheer thee in the days of thy youth, and walk in the ways of thine heart, and in the sight of many eyes. But know thou that for all these things God will bring thee into judgment. Therefore remove sorrow from thy heart, and put away evil from thy flesh, for childhood and youth are vanity. Ecclesiastes chapter 11. So those are good words for us to think about and to live by. We are entering our final days. How do you want to spend your final days, weeks, hours, seconds? What do you want to be doing in these final moments? How do you want to wrap things up? If you haven't given your life to Jesus Christ, I highly recommend it. He is the way, the truth, and the life, and the only way to His Father's kingdom, God's kingdom, is through Him. I hope everyone has a good week, and keep pressing forward. Not all days are happy or cheerful. It's nice just to have a happier, cheerful moment. So, I'll be praying for all of you. I love you all. Until next time, God bless you. Go in peace, and I will talk to you soon. Good night.